All right, guys. So let's start. Okay. So good evening, you all. Right, and let's start this session. And today we are going to discuss further from the last session. So let me share my screen, and then we can start. So guys, if we have any questions, right, before I can start, because we discuss some basic understanding about the working principle of the controllers. We discuss about that, what is my management plane, what is my control plane, orchestration plane, and also we discuss about that data plane. So if you have any questions, do let me know so we can proceed further. If no questions, we can continue from as per the curriculum. Hi, Sharda, Ajay Saini,
Well,
Gaurav, Altaf, Parth and Ravi. I hope
So,
all good, right? Yeah.
yeah, so it is my first class for this SD1 class. So, how many classes we have covered up?
Technically, just theoretically, one architecture. I discuss about the difference between the management plane, control plane, orchestration plane, and data plane. So I can quickly do the recap for you if you want. If you don't have any idea about that, there is no problem for me. But yes, still we are about to start any lab, any deep level understanding. So all are pending. Okay, Sarda?
Okay, that's fine for me. No problem.
All
Yeah.
right.
You can proceed.
So, all right, guys. So let me discuss about the deployment method. That's very important to understand. Whenever you want to deploy the SD-WAN, especially for the Cisco SD-WAN, how you can deploy that SD-WAN solutions. So there are two components. One is the controller, right? Let me draw the line here. So one is going to be controllers and the another is going to be routers. So if we talk about the controllers, we have three components. The first is going to be manager, that is known as the vManage. Second is going to be validator. This is known as the vBond. Third one is going to my controller. Now you confuse. This is also controller. Why another controller I'm writing here? So I'll explain. Don't worry. Okay.
Mhm.
This is the vSmart. So if I talk about the controllers, technically in the SD-WAN language, the controller is basically the central place where we have the multiple devices are going to work together to just, operate the fabric in terms of the routing, policy, configuration. So if I'm just generic talking about the controller in SD-WAN, in that case, you are going to represent all three devices. But recently, SD-WAN, especially for Cisco SD-WAN, they renamed the vSmart name as a controller. So that specially dedicated for the routing plus policy. So don't be confused. If I'm talking the controller, just think about the vSmart, or might be you just think about controller is just representing the vManage, validators, and the controller. That's the vManage, vBound, and the vSmart. If I'm going to deploy these devices, only one option have. These all are going to be virtual device. Virtual device. There is no physical device available in the market. Means I need to deploy these all in the VM. I need to download the image and I can deploy this image to the VM. How can download the image? Let me show you. So if you really know how to download the software from the Cisco Software Centrals, so you can download from there. So I'm just searching Cisco SD-WAN image download, and then you have to go about the software download, software like Cisco Software Central, and you just open that, and then you're going to find the all devices images. So let me show you. You can see you have the vEdge cloud image, we have the vManage software, we have the vSmart software. You can find here the vSmart software. We don't have the vBond software here, so I will discuss why there is no not vBond software is available and how we can use the vBond software as well. But you can download the software from here. This vManage, vBond, and the validator all are going to be there, and based on that, you can just deploy in the VM infrastructures. This VM can be your on-premises VM, means you can deploy in the ESXi, you can deploy in the any KVM. These are the virtualization method which is going to use in the any physical servers. So you have to buy the physical server either from Dell, HP, Cisco, Huawei. Means there are a lot of so there are a lot of company who are building the servers. And after buying this server, you just have to deploy this hypervisor, ESXi or KVM, and on top of that, you have to run this images. Okay, so this is going to run. And if you want to really see how it is going to look like, let me show you one of the example. So this is my VMware XSI, ESXi, and on this I'm running one of the my hypervisor. See, so this is I don't have. Okay, let me use the different server. This one don't have the vManage. Let me try on another server. There should be one vManage. Okay, so this is my vManage. I need to turn on, and this vManage is totally deployed. So 20.12.4.1. So this is basically under the ESXi. So basically, I'm on the Dell server. Under Dell server, I am using the hypervisor that is the ESXi. Under this ESXi, I have the VM that is the vManage. So you can deploy this vManage and vBond and the vSmart, that is known as a controller validator and manager on the ESXi or KVM on the physical server. That is a one method of deployment. This is known as the on-premises deployment. Means you can deploy in your data center or any hub location, but you can deploy the same on the any cloud provider as well. Means if you really want to deploy on the managed service provider, like you have the GCP, you have the Azure, we have the certified cloud like PSI, ISO2, these all the different providers, government cloud. So you can even deploy that location also. And this is known as the cloud-based deployment of the your controllers. But there is no physical devices available in the market. Is it clear to everyone? This is
Yeah.
clear. If you are going to deploy this controllers, means validator manager controllers, this can be only deploy in the your virtual infrastructure. There is no physical hardware available. Ajay, Amit, Gaurav, Altaf, Parth, Ravi, I believe you guys are clear about this. Okay.
So,
Yes, sir, it is clear.
Yes.
just a question. So all those controllers, like validator, a manager, and
Mhm.
this would be that means it doesn't have any specific hardware box like router like that, right? That
No,
can
no,
be,
nothing.
yeah, that can be installed on a physical server, either on
Yes. So
VVM.
what you have to do that, let me
Mhm,
just, means to make it more simple, you have to go in the market
mhm,
and purchase one of the server. Okay.
mhm,
Let's suppose this is your Dell server. So this is going to be your hardware. This Dell server having might be 512 GB RAM. This is very costly. This server are going to be RAM, uh, 10 TB SSD and 96 CPUs, right? This is
mhm,
going to cost you around 15 to 18 lakhs rupees.
mhm,
Okay. So you purchase because company have that much money and they purchase this server. In that server, they deploy the hypervisor that is known as the ESXi. So they can deploy the ESXi. Let's suppose this is my ESXi, this one, which you earlier, this is the ESXi VMware. You can see this is the ESXi. Under this ESXi, you have to create the virtual machine. Like I created this virtual machine. You can go here and create the virtual machine, and you can import the your virtual image, means iOS of the your controllers. So under that, you just have to deploy the vManage. You can deploy the vSmart. You can deploy the vBond. Then they are going to make the networking internally by using the virtual networking, and they're going to make the connectivity together. So this is how it can be done. So this is known as the on data center deployment or on premises deployment. Okay. Another method we have.
Just a question over here.
Mhm.
Is it recommended to install all controller in a single physical box? Yeah, it's
Uh,
different.
Generally, we have the deployment whenever you're going to be make this kind of the connectivity, okay? So
Mm-hmm.
they work in the clusters, even not the single box. Means multiple server are going to be form the cluster by the using the vCenters, okay? So even while one server is going to be down, their backup is already running in the different servers. So they're going to take immediately clone is going to be there and it is going to be restore your services. Well, that is
Okay.
one thing for the one single site. But in production also, we have the backup location. Like DC is one place, DR is one place. So if let's suppose one single server is going to down, another DR is going to be serve your all requirement. So that is how it is going to deploy DC and DR format. Okay, Sharda?
Yeah.
Makes sense?
Yeah, makes sense.
And in case of the Azure, also you can do the same way. In Azure, also you can deploy this controllers like vManage, vBond, vSmart, and they are going to form the connectivity. Similarly, means you have to deploy on the cloud basis kind of the image, and those are going to just form the connectivity. So these two options are available. The third is, let's suppose we are doing the lab. So lab are going to build on the either EVNG, sorry, it's going to be EVNG or might be the peanut labs. So how these labs are going to work? So labs are going to work. Let's suppose I'm going to use the EVNG. So EVNG is going to host means you require one server here. This is your Dell server or might be the HP server. Under this Dell server, you just have to again deploy the second layer hypervisor, that is the EXXI. Now the third layer, you have to deploy the eVNG or peanuts. Under this eVNG and peanut, you have to deploy the controllers. And under this peanut and the eVNG, you can make the nice topology in the your graphical user interface. Generally, in the ESXi, you have to draw topology manually by HLD and LLD. But if you are going to do the lab practice, I would suggest use the means definitely I will share this lab topology. This is how we can using right now. You can see this is the purely EVNG based topology. So even we are deploying this vManager, vBond and vSmart, but they are basically under the ESXi, and by using the EVNG services, we are just hosting these controllers and routers. So this is the third way we can use the deployment method. Okay, so if I talk about the controllers are only going to be your virtual. There is no hardware. But if I talk about the routers can be your hardware. Let me open one of the PPT. Routers can be your hardware and can be your software. So let me see if it is available here. Uh, no, it's not available. But yes, if you go for routers, I have another PPT. I'll bring that. So those routers can be your hardware, can be your software. Means if you are using the vEdge router, so vEdge router like physical box vEdge 1000, vEdge 2000, right? vEdge 5000. These are actually you have to purchase the box from the your vendors. Like Cisco is going to give these boxes, and based on that you can install. Like similar, like you have the router like ASR 1000 router, ISR 4431, right? We having this kind of router ASR, ISR. So these boxes also can be installed. These boxes also support the SD-WAN, right? These
Yeah.
boxes also can support the SD-WAN, but these are physical boxes. These boxes known as the cEdge. Why cEdge? Let me explain. These are the vEdge because the Viptela boxes can be installed in the any locations. Now, if I want to talk about the virtual, so virtual also these boxes are going to be used. Means if I want to use the virtual edge, so there is the vEdge cloud. This box is going to be used as a virtual deployment. Means if you want to deploy this in any ESXi based platform, any KVM based platform, any EVNG based platform, any cloud based platform, that can be also deployed. Means this can be used for the any kind of the cloud based, ESXi based or KVM based. Similarly, for the cEdge, we have the CSR 1000, right? We have CAT 8000 series of the router. These are basically virtual devices, and this can be also deployed. So you can see in this lab, you have this router that is the CSR 1000. This is a virtual device, and this is also we have the vEdge cloud. You can see this is a vEdge cloud. The image is basically vEdge cloud, and this is a virtual device. And similarly, if you want to see the 8000, so you're going to find this router. Probably let me see if it is available or not. So on this not available, let me open another VMware. I have the another SD-WAN router that is going to act as a my see. So this is my router, ISP router. This router, if I open, this is basically going to be I need to turn on this version, but this is a actually CAT 8000 version. So if I go here and search you Cisco vManage device list, so you're going to find a lot of devices. See, so Catalyst 8000, this series is going to support, ASR is going to be support, ISR is going to be support, this is a Meraki series. So CSR is going to be supported. So these all are going to use for the any your SD-WAN solutions. But if you are going to use this all version, this generally known as a cEdge, because this is a Cisco developed product. Okay. So that's why it's known as a CS devices, means Cisco Edge. But there was another company, Viptela Edge. So if you just search the vEdge devices, so you're going to find these vEdge devices. They are the hardware devices. You can see vEdge 100, vEdge 1000, vEdge 2000, vEdge 5000. These are the quite popular 1000, 2000, 5000. And also we have the vEdge cloud. So if you have the physical boxes, you can use in your productions. If you don't have the physical boxes, you can go and use the virtual boxes. But this virtual routers can be used for the any physical method, can be virtual method. But controller is always going to be used for the any only virtual method. Is it clear to everyone? Let me show you one of the PPT also. Let me bring that PPT so I can show you. Give me 1 second. Hold on, guys. So let me open this. So if I go down, say here. So this controller can be only ESXi or can be cloud hosted, but you can see they are the physical boxes, especially the Viptela. This can be different hardware specifications. This device having the 1 GPS AES-256 encryption they can support. That is a one rack unit device. It have the 8 GB port that is going to support 10 Mbps, 100 Mbps, 1000 Mbps. TPM chip is installed in this particular box. This can support 4G, 3G via USB or Ethernet, security, QoS, dual power supply, low power consumptions. So more bigger box you're going to take, more bigger feature you're going to get. And then the lower version box is also available. This not include the 5000 series of the vEdge, but yes, we have the 5000 for the data center. That is also going to be used. Okay, so I hope you guys have the good understanding about at least basic understanding of the controllers. Now, what we have to understand now, if you want to build the controllers, right? So how controllers are going to be communicate to each other? How controllers are going to communicate to each other and how they're going to build the fabric. So to understand that, let me understand one of the key component. Give me 1 second. Let me see if I find the PPT. Okay, so let me open this slide. We have this box, right? This box have the multiple component. Means this is legacy routers. This legacy router have the multiple component. We have the IO module, we have the switch fabric, and we have the control plane. So whenever you're going to take any decisions from the any kind of the communication, let's suppose this PC connected on this port and want to communicate with another PC which connected to another port. This is a PCA and this is a PCB. This one having IP address 1.1.1, this one having IP 2.2.2. If they want to communicate, how the communication is going to be happen? So basically the communication is going to be happen definitely when the packet is going to land on this particular physical port. That's known as a data plane. IO module is the input output module. This also known as the data plane connectivity. So your packet is going to land in this particular interface. Once they land, they will consult with the control plane, which is basically nothing your routing engine. So they are going to talk to routing engine how to reach to my destinations. So based on the routing, you are going to get the best path to reach the destination with the exit interface. And then your packet is going to punt to this interface. But to reach from this location to this location, see, this is the separate box, box 1. This is the my box 2. So how they are going to talk? So they having the S6, the whenever you're going to insert this card, they are going to connect with the backplane. And this is going to make the one switching concept, means they are going to connect the circuit and they are going to make the full circuit by using the A6, by using the A6. So the broker who is just making the connectivity from my control plane and data plane, that is known as a switch fabric. If this is not going to be there, these two modules never going to be communicate. So this is going to make the connections for any packet coming from the any LAN and want to go for the any other LAN network or might be the WAN network. Via switch fabric, they are going to control plane, and based on that, they're going to make the communications. So this architecture is known as the closed box architectures. Means within the box, everything you have the control plane, data plane, and the switch fabric, and then you're making the full circuits, and then you're making the communication. But if you are going to learn the SD-WAN, you have to decouple these all three things, and you have to put in the three different locations. And then we have to make the connectivity, then only your communication is going to be happen. So your control plane is going to be somewhere else. Let me show you the SD-WAN architecture, decoupled architectures. So this is my SD-WAN solutions. In this SD-WAN solution, you can see one place we have the IO module. Still we have the IO module. That is a data plane. We have the control plane module. That is my control plane where my routing is going to be happen. So data plane and control plane, these are the two different locations. This might be in the USA. This might be my site is in India. So how, if there is one PC is connected here now, if one PC is connected, PC A is connected here and want to talk to PCB, then how they're going to communicate? This IP is there 1.1.1. This IP is 2.2.2.2. Basically, these are basically end routers. These routers are having the physical connectivity to the end clients. But if these two clients want to communicate, these routers are actually the brainless routers. They do not have the brain how to communicate. So to make the communication, they will consult with the routing engine. And if the routing engine say yes, they need to be communicate, then they have the communications. But how they can reach the routing engines? For that, they are going to use the switch fabric. Switch fabric is going to be there, who is going to make the connectivity from your data plane to the control plane. So then it is going to make the full circuit. So earlier the switch fabric was A6, means in a previous diagram, switch fabric was your circuits A6, means the card was basically jack in and then they make the complete fabric. But here my controller are in the USA, my data plane in India. But what is my switch fabric? That is my ISP. Means any MPLS circuits, any internet, any broadband, any 4G, 5G LTE, that is going to be there to just use to make the full circuit. And this is how your SD-WAN architecture is going to look like. Means any router you're going to use in the SD-WAN, those routers are going to be completely brainless. For the SD-WAN routing, these routers are going to support two kind of the routing. One is the SD-WAN routing protocol. That is a OMP, Overlay Management Protocol. Another is a legacy routing protocol, like BGP, OSPF. If there's cEdge, then support the EIGRP also, static routing. These all are going to be supported. So for legacy, they have the brain. But if you talk about the OMP, they don't have the brain. Always routing is going to come from the controllers. And these are going to be act as my switch fabric, which is going to make the connectivity from the branch to the controllers. If this controller is not going to be built, you cannot make any communication. Any doubt till here, anyone? Gautam, Altaf, Rabi, Amit, Ajay, Sharda. Please, guys, any questions or we are good?
I'm good.
Okay, everyone?
Yeah.
Yeah, we are
All-
good. We can move ahead. Yes.
Okay, good. So now what we have to do that in our lab topology, Altaf, okay, that's fine. There is no configuration at all. These devices are completely blank. Okay. And we have to build the brain. That is my control plane. So let me explain the topology. This is going to be my control plane. Means this is going to act as a brain of the SD-WAN. Controllers, brain of the SD-WAN. Okay. These routers are going to be act as a data plane. So we have the vEdge routers, we have the cEdge routers, we have some firewalls, we have the LAN connectivity. So this is going to act as my data plane. This router, this router, this router, this router, this router, and this router. So brain is sitting in the site 100, and then again we have a different site 3, site 4, site 6, site 200, and site 5. And now we have to make the switch fabric. Without switch fabric, these brainless devices cannot communicate with the controller. And if they are not going to communicate with the controller, they cannot make the connectivity to branch because they will not going to get any routing. So for that, we require the switch fabric. So this ISP is going to act as a switch fabric. And by using this switch fabric, we are using the MPLS and Internet ISP. Okay, in this lab topology. So we have to start doing the configuration from the scratch. Means no configuration, day zero configuration. So we have to understand how to take the GUI access of the my vManage, how to do the first time setup for the vManage, and then similarly we have to understand for the other devices also. Clear? One more thing you have to understand, there is a concept of the underlay and overlay. So what is underlay? Because it's very important and it is always going to required. Underlay is your basic IPv4 reachability. Means if you want to build any kind of tunnels, in this SD-WAN, we have to use a lot of tunnels. Like you're going to find DTLS tunnel, you're going to find TLS tunnel, you're going to find IPsec tunnel, you're going to find GRE tunnel, you're going to find the BFD tunnel. These tunnels are going to be there. Also, you're going to find the OMP routing protocol that is going to build. So if I'm going to build these all these tunnels are basically always going to act as a overlay. Means if you want to build the tunnel, this is going to fall in the overlay. Any tunneling protocol like DMVPN, we have the GRE over IPsec, we have the VXLAN, we have Libs protocol. These all are tunneling protocols. So to build the tunnel, what is a prerequisite? So if you want to build the overlay, very first thing, you should have the underlay. If you don't have the underlay, you never ever can build the overlay. Simple example, let me show you. Simple example. Let's suppose there is a requirement there is a requirement, there's a Delhi branch and another is the Pune branch. This branch having the one router, let's suppose R1. This Pune also have the one router, that is the R2. Now you have a requirement to form a tunnel between these two locations. So what is going to be required? You have to go to the ISP, any ISP, might be Jio, Airtel, Vodafone, any third-party ISP. Even you can get quotation for the global ISP as well. So you require the ISP link, which is going to be, let's suppose you taken from the Jio, okay, or Airtel. These links are going to be terminate here, and there is going to be public IP address. Means here you're also going to get the public IP address like 112.10.10.2, here .1, here 110.10.10.1, and here 2. So these public IP, first of all, these hopes should be reachable. These hopes should be reachable. And then end to end, you should be able to reach. When you're going to build, this is known as the underlay connectivity. So you must have to build the underlay connectivity. So what is the underlay? You must have the basic IP reachability. IPv4 or IPv6 reachability. How you can do that? By using the logical addressing, routing, or physical cabling. Means you require the IP addressing, routing, and physical cabling, then only you can build the underlay. Once you have the underlay connectivity, then you can build the tunnels. Means if you want to build a tunnel like IPsec tunnel from this location to this location, GRE tunnel, you can build anything. GRE, IPsec over GRE. So that is the prerequisite. Means you just have to build the underlay. If there is no underlay, you cannot do anything. I hope it is clear to everyone. Same thing in our SD-WAN. If I want to build any communications, as I mentioned that SD-WAN is going to use a lot of tunnels. They are going to use the TLS tunnel, they are going to use the DTLS tunnel, they are going to use the IPsec tunnel, they are going to use the GRE tunnel, they are going to use the BFD tunnel, OMP also going to run. So this only going to possible once we have the underlay reachability between the all devices. So this is the prerequisite for the any SD-WAN deployment. Any SD-WAN deployment, it's not related to Cisco, it's not the Juniper, it's not for the Versa, it's not for the Velo Cloud, not for the Silver Peak, not for the Kato, not for the Zscaler. Simple thumb rule. You must have the underlay. If you don't have the underlay, you can't build any overlay. All right. So I'm assuming everyone understand this concept. No doubt. If any doubt, let me know. Moving forward. So in the similar manner, if I want to build the connectivity SD-WAN fabric between these controllers, so first these controllers should be reachable. Means all controller should able to talk each other. Means their IP reachability is there. If there is no IP reachability, they cannot talk. So we have to build the IP reachability, and for that, you can see they have the connected cable with this DC switch, and this is the IP schema for the controller. 123.10.10.12, 11, and 10. So this is how they can build the IP reachability between the controller. Now if they want to build the connectivity with the branch location, then they have to build the IP reachability till here. So this circuit should be up, this circuit should be up, this circuit should be up, this circuit via the internet. Similarly, if they want to make the connection with the MPLS, then they have to use this circuit where BGP is going to use. So entire fabric, we have to build end-to-end IP connectivity. So let me start doing very first thing, vManage configurations. First, very day zero configuration, when you want to build that, you have to onboard the manager. Without manager, you cannot proceed with any onboarding process. So we have to think how we can onboard the manager. So I will simply, what I'll do that, I will turn on this device. Just click on here. You're going to turn on this device. You can turn on this device. You can turn on this device also. And you can turn on this device also. and you can turn on cEdge. First, we'll complete this configuration, then we'll move to the other locations. It will take time, okay? Also, I will turn on this management PC, which is connected behind this management. Once turn on, just double click on this device, okay? It is going to be like this. Hold on. Let me refresh and I'll open again. So I will click on it. Okay. So it will start booting very soon. You can just turn on this device also. So you can see it is start booting this, my vManage. PC also booting. I can turn on this vBond also. It will also start booting. I will turn on this vSmart also. So these all are going to be boot up very soon. So it will take a little bit of time. So we have to wait patiently until it's going to boot, because we have to start doing the configuration from the day 0. So let's wait. So whenever you're going to boot the vManage, it will take 3 to 5 minutes to get ready, because it's a very high processing image. It's required 16 GB RAM and 100 GB storage to just, make them functional. So it's a very, powerful device. So it's take a little bit time to just, get start working in normal mode. So once you start, just wait for 3 to 5 minutes, then it is going to be ready to serve. So it's booting up. Let's wait for a while. Okay, so now you see your system is ready now. Once you find this message, system is ready, that means everything is good. You just press enter. Default username of this device is going to be admin. You just have to put default username admin here. And password also going to be admin. Means username, you can write it. Let me write it here. The username default admin, password also admin. So any devices you are going to use for the SD-WAN, you always have to put this username and password admin. But after first login, you have to change the password. So I will change the password as a admin again, and I will re-enter the password admin. Now, after doing this, you can see there is a 2 options coming. It's asking this VDB, HDC, right? So these are basically nothing. These are the basically hardware drive. So to run this vManage, you have to select the 100 GB hardware drive, means hard disk for this vManage. And also your system should have that much space, means where you're building, means in laptop you're building, that your laptop should have the 100 GB free space. If you're building in the server, then server also have the 100 GB free space. If there is no 100 GB free space, you cannot build this lab. So for that, what we can do that, I use the 1, because I need to use the 100 GB. So click 1. Then it is asking you would like to format. Yes. Always best practice, whenever you're doing the first time build, format it. And then it will take a little bit more time to just get this done. Once it's done, then we'll proceed with the next step. So wait for a while. So let's wait, guys. Okay, so it will take a little bit time. And once we'll get the message system is ready, then we can proceed. So let's wait. We cannot do anything until it's going to be ready. Too many argument, run line 43. So it's a normal message. Sorry, guys. So you can see here. Now it's all ready, right? It's coming too many argument. It's going to be away after some time. Initially, when you're going to boot, it will give such kind of the errors, but it is going. But if you go and run the command show run, you see there's a default configuration available on the vManage, and there's no much configuration. Only some default configuration is available. You're able to see like we have the system configuration, nothing. We have the username, we have the password, and okay, it's restarting again. So we just have to wait for a while because it's get restarted again. So initially it takes time because it's a very heavy image, so it's need a proper space to run this particular image. Sometimes it's happen, it's restart, sometimes it's get delayed and all. Sometimes it's very fast. So we just have to wait. Wait for 1 minute. Okay, so now it's all cool. Just wait to get system ready. Then we can proceed. Okay. So you can see when it was booting, spike was almost 100% for CPU. So that was the reason it was getting like start. So if I just try to put username and password, it is not going to take. It's showing the authentication failure. It doesn't mean I'm putting the wrong username and password. It's mean still your system is not ready. Because you're going to get a warning message once your system is going to ready. Like you can see this one. Your system is ready. Now if I'm going to put the username and password, this is going to take the username and password. Now we are good. Everything is settled for this particular vManage. There is no issue now. Now if you go and run the show run configuration, so in this you have the default configuration. You can see system configuration. You don't know what is system configuration. I will explain. There are some username, password. There are some user groups. There are some login configuration. There are the VPN configuration. VPN 0, 512. So what is this all things? We have to understand what is the VPN configuration, what is VPN 512 configuration, what is system configuration. No other configuration we have. Very small configurations. You see, system configuration, user group, we have net admin, operators, tenant admin, user admin, we have Cisco tag read only, Cisco tag read write only. These all users are created and their user group also created. But we also seen there is a VPN configuration 0 and 512. So I will explain this few minutes. Give me just few minutes. Now let's go under this PC and let's try to understand why this PC is needed. So to operate this vManage require the GUI access of the devices. Means vManage can be operated in the CLI, but everything, whatever you're going to do that for the configuration, troubleshooting, that is via the GUI. So to get access to the GUI, we require the PC and we require the browser. So that's why this PC is here and this PC password is going to be 123. So this PC password is 123. So you can just take a note. So I'll just simply put the password 123. Done. This password is done for this particular PC. You can set up the good resolution for this PC. How you can do that? Just right click because the window is very small and just click on this particular skin resolutions and you go here and 1440 apply, keep changes, okay, that's all. So your PC size is little bit bigger. What is the next step? For this PC we are going to use the IP address 192.168.10.0/24. So what I can do that I will give this NIC card IP.10 and on the vManage on the Ethernet 1/3 means Ethernet 3 I will give that 1. But in your lab topology, might be this interface is going to be Ethernet 2, 1, anything could be there. So accordingly, whatever the interface written on the your LLD, means this topology, you assign the IP address. So let me go in PC and assign the IP address. So I'll go in the PC, I'll go in the network, properties, and change retro settings. And here I'll go and assign the IP address. This is my network adapter. And I will go here and IP address is going to be 192.168.10.10. Subnet mask gateway, if you wish, gateway.1 you can give, that is my vManage IP address, but it's not mandatory. It's optional, but let's give that. Without gateway, even it's going to work because they are in the same broadcast domain. And that's done. Click OK. And you can verify the current IP address of the PC. Just go in the CMD and just check the IP config. This is the IP and try to ping 192.168.10.1 and it's not pinging because IP is not configured. So PC already we assigned the IP address. Now the major challenge is going to happen how to assign IP address on this interface. Ethernet 3. How we can assign IP address? So if I just go in the vManage and if I go in the configuration, if you want to go in the configuration, you just write the configuration terminal command. Similar to the Cisco router, you can use the config t command that is going to work on the vManage also. Even this vManage, vBond, vSmart, every device is going to work. cEdge have some different command. cEdge doesn't support the configuration terminal. They support config transactions. So I will explain how this is going to be look like on the cEdge devices later on. But for time being, you can see this vEdge is supporting the your config terminal. Click enter. Now I need to assign the IP address 192.168.10.1 on this interface. Can I do that? Just try to interface. This command is not working. This command is not working. Unknown command. So you cannot directly assign the IP address on the any interface in SD-WAN fabric. Any SD-WAN devices if you have. Okay, let me write the device. This especially Viptela device. If you have the vManage, vBond, vSmart, or vEdge router, you cannot assign any IP address directly on the interface. So how we can assign the IP address? What is the method to assign the IP address?
Through VPN only.
Yes. So to solve this problem, we have to understand that is the VPN concept. That's why you can see if I run this command show run, we have the VPN 0, VPN 5 and 2. So we have the three category of VPNs. Okay. VPN is virtual private network. But in the SD-WAN, this VPN is going to be equivalent to VRF, virtual forward routing, exactly same. Means you think we are going to do the VRF work. So what is VRF? Anyone know? What is the VRF, guys? Amit, Gaurav, Gautam, what is the VRF? No idea?
It's virtual router.
Can you just define a little bit how VRF is going to look like, how it is going to define? Anyone just try? I'm very surprised.
It is a virtual router. It is going to maintain separate routing table instances within the physical box, single
Yes.
physical box.
That's
Virtual routing and forwarding.
so router by default, how many routing table is there? One router by default, how many routing tables there? By default,
One.
one. That is the global routing table, right? But if you
Yes.
want to segregate, you want to keep one global routing table, you can do that. But you want to split this routing like VRF A, VRF B, VRF C. So what is going to happen? By default, global cannot talk to the VRF A, VRF B, and VRF C, and vice versa. You cannot make any communication between the all virtual router and the global router because it looks I have a single physical box but have the multiple routing instances. And those instances are completely isolated and they are not going to allow any communication to each other. Similarly, in the SD-WAN, we have the VPN, virtual private network. Virtual private network equivalent to VRF. We have the three category. We have the VPN 0, we have the VPN 512, and third one is the VPN 12511, 5132655527. So this is the three range of the VPN we have. Okay. Anything you are going to configure related to the WAN, any interface you're going to configure related to the WAN, that's always going to part of the VPN 0. Make sense? Anything. If you want to configure any WAN interface, any WAN facing circuits, you just have to use the VPN 0. Anything you're configuring for the LAN, okay? This is known as the VPN 12511. You can take any range from this particular number. This is from the LAN. This is known as the, yes, please go ahead.
Service VPN, I mean. Yeah.
Yes, service VPN. This is known as the transport VPN. Clear? Anything you're configuring for the management, you have to use always 512. This is known as the management VPN. Clear? So any circuit, make a special note in your notebook, or it might be a digital note, whatever you want to do that. We always have to use 3 VPNs, and these VPNs are going to be always useful. For any WAN connectivity, always go in the VPN 0 and configure the WAN interfaces. Another configuration. Any LAN, you go in the any range, you have to select the range as per our choice. I will show you. But range should be only from 12511 or 513 to 65527. Anything from management, we can go from the 512. So you guys tell me.
Just a question over here.
Yes.
Is this VPN that means standard for all the vendors? Yeah,
No. It's only for Cisco. This is for the Cisco only. There is no VPN concept other vendors. They have a different concept. This is just for the Cisco SD-WAN. Okay, Sharda?
Yeah. Bursa, it should be different, correct?
Different. Every vendor have different terminology, different type of configurations. Now, you guys tell me, what is the correct VPN I should choose to configure this interface? It's
VPN.
LAN, WAN, or management? Any guess?
Management.
Yes, management VPN should be there, because we are going to see controller. See, LAN is going to be only where user is going to sit. So LAN can be the branch location. Data center could be LAN. Okay. LAN cannot be on the my controller. Controller should be only management access. No user is going to sit in the controller locations. So LAN is required local network where I have to connect a server, user, and all. So this is going to require my management VPN. So I will go here and configure this interface as an VPN 512. Then I'll go to the interface ETH3, IP address 192.168.10.1/24, no shut. And if you want to show configuration, what configuration I'm doing, you can just run command show configuration. This configuration I'm doing that. If you want to apply this configuration, you have to write the commit. If you're not going to write the commit, this configuration is not going to apply on the router. So you just do show run again. Say this is the new configuration. And now if I go in the PC and try to ping this IP address, it is pingable. So now if I'm pingable, then I can access the GUI of this particular vManage. How? I need to go in the browser. And I need to do this configuration of this particular my SD-WAN. So I'll go here, HTTPS 192.168.10.1. Click enter. So it is trying to establish the connections. So wait for a while. processing request. And now you're saying the connection is not private, just certificate error. So you just ignore it, click continue with unsave, and then you're going to get the dashboard of vManage, GUI dashboard of the vManage. So I'll need to put the username here, admin. Password is also going to be my admin and login. That's all. Now I have the baby lab, means very easy lab. That is my vManage GUI access and how to set up the vManage. Still, nothing is configured. It's completely blank vManage. Even this vManage is invalid. There is no certifications. So tomorrow we'll see how to do certifications, how to onboard this vManage and all, right? But I believe we are good for today because just 1 hour class. I have to jump in other sessions. Any questions, just let me know, guys. Or we are
Yeah,
good.
just only one question. How we got management for that we manage we configure? Then how did you get the GUI access? Just we have simply point-to-point IP address, right?
Yes, nothing. Just you have to ping, then you just have to, this services HTTPS is enabled for this management interface already for the vManage.
Even
So it
by
is going to,
default goes, yeah.
by default it's enable. If you want to block, you can block that also. But by default it's enable and you can just access that particular circuit.
Okay, fine.
Okay. Okay,
Okay.
guys. So chalo kal milte hain and we continue from here. Thank you guys. Thank you so much. Please come with a question in the
Thank
first
you,
half
sir.
and we can connect
Yep.
tomorrow and we continue from here. Thank you. Bye-bye. Take care.
Can I get a recording for these?
Yes, definitely. Just ping to support team. They will give you. Okay. Or might be your
Okay.
counselor. Okay. They will arrange you the recording. Not today
Okay.
because this is a cloud-based recording. So going to be ready by tomorrow only. But you just ping them. They will give the recording on the portal.
Okay.